Мы в эфире. Hello everyone, welcome to our third ODS Paris online meetup. And as usual, I would like to introduce you to ODS community. It's a Slack community where you can find a lot of channels related to Kaggle competitions, and also you have there channels related to frameworks what were developed, and you can ask directly questions there. So how to join? You just fill the form at ODS AI site, and then I think you should wait 2 or 3 weeks for approval. So yes, I would like also to introduce you to Anton Doroshko and Evgeny Bazarov, who made huge impact for this happening. And my name is Olga Ishimbayeva. So next competition, new competition on Kaggle. It's a Google landmark retrieval. But there is one thing that you can only submit TensorFlow models. But it's still interesting, and this competition repeats every year. So it's a third edition for this competition. So if you are interested in it, in this type of data, I think it would be interesting to you. Yeah, and 1 month until the deadline. So today we will talk about Kaggle competition with sentiment extraction, and Artsem Zhyvalkouski. He will tell you his first place solution, and he will tell you also how he and his team won this competition. Don't miss it. Also, we will have a special talk from Philipp Singer, who will tell us about how he won solo gold medal, and due to this competition he became a grandmaster finally, and he was happy for it. Then we will have time to ask questions. Artyom, so you can ask questions directly in the chat, and then we will just ask questions after all those presentations. And at the end we will have some video networking, and also you will find a link in the chat. Artyom, he is data scientist at Tokyo City University, and he started to play Kaggle 6 months ago very seriously, and he already received a lot of medals. Congratulations, Artyom, for the golden medal and first place solution, and also for your other medals. And yeah, so let's start, and I would like to pass the control to Artyom.
So hello everyone, my name is Artsem, and today I'm going to talk about my team's first place solution in the recent tweet sentiment extraction competition on Kaggle. So without further ado, this is the agenda for my talk today. So first of all, let's start from the background. This is me. I'm originally from Minsk, Belarus, and currently I'm studying computer science at Tokyo City University in Japan. I have experience doing research and development in computer vision, natural language processing at a startup here in Japan. I also love reading NLP academic literature and enjoy learning new languages. I'm fluent in Belarusian, Russian, English, and Japanese, and right now I'm interested in French and Korean. So this is my Kaggle profile. As you can see, participating in this competition got me almost to the 100th position in the absolute rankings. So why did I actually join this competition? Firstly, I wanted to kind of familiarize myself with the current state of the art in NLP, which are transformer-based models. Secondly, I wanted to learn about PyTorch and Hugging Face transformers libraries. Also, the dataset in this competition was quite small, so no extra powerful resources were needed. I actually did a lot of my training using only the Club Pro GPU. And finally, the task seemed pretty interesting and unusual, and I had enough time to invest in this competition. Next, a few things about my team. So Theo, he is a student in applied mathematics and machine learning, and together with another member, Anton, they reached the 10th place in the Google Quest Q&A competition. Also Hiki, he has background in NLP, QA, and he reached the 10th place in the TensorFlow 2.0 mention answering competition. Moving on, let's talk about the competition itself. So the task was for a given tweet to predict which word or phrase best supports the labeled sentiment. For example, like here we have a tweet. I really, really like the song Love Story by Taylor Swift. And its sentiment is positive. So our goal is to predict a continuous part of the tweet which describes the sentiment. In this case, it's the word like. Also, we had negative and neutral sentiments. Not for all, but for most of the neutral tweets, the selected text was basically the tweet itself. So from my personal understanding, the application of this task in the industry may be that some businesses may want to know exactly why people think certain things about their product and what kind of emotions they have about it. So as the data, we had 27,000 tweets as the training data, and the public and private test sets contained 4,000 and 8,000 tweets respectively. So the evaluation metric was word level Gcard score. So this is the formula for the Gcard score. Some people also call it intersection over union, or IOU. So in the numerator, we have the cardinality of the intersection between two sets, and in the denominator, we have the cardinality of the union between them. So this is the code for the metric that we were provided with, and the function takes two strings, one of them being the target string, which we need to predict, and the another one is the our predicted string. Sorry. As you can see, before calculating the Gcard score here, the first lowercase both strings and then split them by spaces. After that, the overall score is computed by taking the mean for all the tweets. One of the main problems in this competition was that some of the labels were pretty noisy. For instance, here we have why adore or as word or e best as selected text, and it looks like some labels were shifted so they contain parts of the previous words. Okay, now let's talk about our solution. Almost all tasks in NLP now are solved with transformers, and our solution is also based on them. So transformers have become default in state-of-the-art NLP. Their main advantage is that they're pre-trained on a huge amount of text. The disadvantage is that they're quite heavy and long to train. In this particular competition, transformers can be used in either named entity recognition or question answering setup. And for everyone, the question answering setup worked best. So this is how you can use the QA setup with transformers for this competition. So the question here is the labeled sentiment, and the answer is the support phrase. As input, we feed the sentiment followed by the sentence tokens. Then it goes into the transformer, followed by a linear head and softmax to predict two sets of probabilities. One of them being the probability. So for each token, the probability that the token is the start of the text. And another set is for each token, the probability of the token being the end of the text. Now I will tell about the transformers that I built. I actually built 4 models: Roberta Base Squad 2, Roberta Large Squad 2, Distill Roberta Base, and ExcelNet Base Cased. As you can see, some of them are pre-trained on Squad 2.0, and actually those models performed best, which proves that not only does domain pre-training work, but task pre-training works as well. I modified the architecture by taking average and max poolings of all layers without embeddings. I also used multi-sample dropout, ADMW optimizer with linear warm-up schedule, and came up with a custom loss, which I called Jacquard-based soft labels, and I'm going to talk about it later. The best single model for me was Roberta Base Squad 2, which had 5-fold stratified cross-validation score of 0.715. So this is the architecture that I used. Average and max poolings are concatenated and fed directly into the linear head with MSD. A brief explanation of multi-sample dropout. Basically, you apply dropout multiple times with different masks, and then average the results. This works pretty well. This worked pretty well in many NLP competitions, and is proven to kind of make your network converge faster and produce more stable results. Also, I used ADMW optimizer from the decoupled weight decay regularization paper and the linear warm-up schedule. The learning rate is linearly increasing during the warm-up phase, and then linearly decaying to 0 until the end of the training. Next, this is the custom loss that I came up with. Basically, it's a modification of simple label smoothing. So the problem is that the original loss in the question answering task is cross entropy, which doesn't directly optimize the Jacquard score. So my idea was to somehow penalize far predictions and reward close ones. Alpha here is a parameter to balance between regular cross entropy and the Jacquard-based probabilities. Also, I noticed that it may be beneficial to penalize far predictions even more. So I added a square term, and it worked best for most of my models. For example, this is a plot for start and end target probabilities for some certain tweet. And actually, because of this loss, my models produced pretty decorrelated probabilities with respect to the regular cross-entropy or smooth cross-entropy ones. And that's why I think they were crucial to our ensembles. Now I'm going to explain my teammates' models. First of all, Theo's models. He also trained 4 models, BERT based on cased, BERT large uncased with whole word masking, still BERT, and Albert large V2. The architecture he used was MSD on the concatenation of the last 8 hidden stays. He also used smoothed cross-entropy loss and discriminative learning rate from the ULM feed paper. Basically, you reduce your learning rate exponentially, depending on how far the layer is from the head of the network. He also used sequence bucketing, which is a technique when you create your batch with sequences of similar length, and it can speed up your training pretty much. Moving on, Anton trained BERT base and BERT tweet, which is a new BERT model that was pre-trained on English tweets. He used the same architecture as Theo. Also, he used smooth cross-entropy loss and discriminative learning rate. And also, he modified the merge.txt file for Roberto Tokenizer with some custom tokens. Finally, Hickey trained 2 Roberto models, base and large one. Instead of appending sentiment token to the start of the text, he appended it to the end. Also, he used CNN and linear layers on the concatenation of the last 3 hidden states, and his loss was standard cross-entropy. Okay, so far so good, but we have some problems. First of all, the transformers are token level, which means we can't really capture the noise pattern, which is clearly character level. Secondly, there is no obvious way to make transformers character level. We can actually use character level RNNs, but they are not even nearly as powerful as transformers. Another big obstacle is that we cannot simply blend models with different tokenizations, for example, like Roberto and BERT. So we came up with a solution, stacking. First, we convert token probabilities from transformers to character level by assigning each character the probability of its corresponding token. Then we feed out-of-fault character level probabilities from several transformers into a character level neural net using stacking. So this is our stacking pipeline. So here we concatenate several transformers with sentiment and character embeddings. And then using the character neural net, we predict the start and end probabilities on the character level. Actually, we came up with 3 different architectures for character level neural nets. First one is a recurrent neural net, which is based on bidirectional LSTMs with skip connections. The second one is convolutional neural net, which used one-dimensional convolutions with batch normalization. And the third one is WaveNet, which was inspired by the recent Liverpool competition. I believe there wasn't any particular reason for using it, just to simply add diversity. Some more details about the character level neural nets. We trained them with the ADAM optimizer linear learning rate decay without warm-up, smooth cross-entropy loss, stochastic weighted average, which is basically a technique to stabilize the results by averaging weights for different epochs. Also for predictions, which resulted in the start index being greater than the end index, we just predicted the whole text. So what we have now is a bunch of first level models and different second level models. If you have some experience in tabular data competitions, an obvious next step would be, yes, to stack more layers. So this is our first final submission. We used 12 first level models and 4 second level models, and finally averaged the results. Also, please note that for different second level models, we used different first level inputs for diversity. And this was our winning submission. We also submitted another ensemble with a bit lower score, but it still would have given us the first place. We also did some pseudo-labeling. We used one of our blends to pseudo-label the public test data using the approach from the Google Quest Q&A first place solution, which is a leakless approach, because for each fold we add pseudo-labels that we get from the model that has only seen this particular fold. Then, for each pseudo-labeled sample, we calculated a confidence score by taking min-max probabilities of the start and the end. Then we used a threshold of 0.35 to cut off low confidence samples. This resulted in a pretty robust boost for many of our models. So here are the final standings. As you can see, there was a bit of a shakeup, but we trusted our cross-validation and luckily survived it. Few words about the things that didn't work for us. So things like named entity recognition approach, image segmentation approach, different kinds of sample weighting, different kinds of other transformer architectures like T5, BART, GPT-2, etc. We also tried to build a character level transformer model. We tried different kinds of pre-trained embeddings like fast text and Flare. We tried adding statistical information like number of words, number of spaces, or number of punctuation marks, etc. We also tried using XGBoost as second level model. We tried to extend our stacking to third level models, and we tried a lot of different pre and post processing techniques, but none of the things that I've just listed worked, unfortunately. Now I'm going to talk about the so-called magic that many teams found, and even more teams didn't, but really wanted to. So closer to the end of the competition, we found that the noise actually comes from the consecutive spaces in the data, and they probably were removed during the annotation process, but the annotated indices were not changed accordingly, which resulted in noisy labels. Resulted in a shift. sorry. So to leverage this magic, we can do pre or post processing and align the predictions accordingly. The reason why we didn't actually use this magic is we found it pretty late and didn't have enough time to leverage it. And eventually our second level models learned the pattern pretty good enough and even outperformed simple pre or post-processing techniques. Now we talk a bit about other solutions. So these are the key points from the second place solution. They also found the magic and did pre and post processing accordingly. They modified the batch sampling process by sampling tweets equally according to their sentiment. So as you can see in this plot, this resulted in much more stable results. Also, they used a kind of re-ranking model as follows. They stored top n candidates from the base model and assigned a step 1 score. Then they trained a Roberto model to predict the Jaccard score for the candidates and called it the step 2 score. And then they simply chose the best one by step 2 score plus step 1 score multiplied by 0.5. Moving on to the third place solution. This is their first model. During training stage, they first predict the start index, and they concatenate the target hidden state of the start to all of the hidden states and predict the end index. And the inference stage, they select top k hidden states for the start, and for each of them, they concatenate them to all of the hidden states and select top k hidden states for the end, and which results in k by k combinations. Then they take argmax over the multiplications. This is their second model, which is an interesting one, because here, as you can see, they also used a character level model. However, instead of stacking, they replicate the hidden state of the transformer for each character and apply a character level GRU unit to predict on the character level. So to conclude, first of all, transformers are perfect for question answering tasks. Next, PyTorch and Hugging Face libraries are extremely powerful and very convenient to use. Also, you actually can extend transformers to character level, which was a surprise for me. One more thing, diversity rules. What I mean by that is large diversified ensembles are useful in deep learning competitions too. Next, the annotation process is a very important step. So, as we saw, mistakes can result in completely different models, so we have to be careful with that. Next, teaming up is very rewarding. Teaming up is a wonderful way to learn from other people, train your communication abilities, and simply enjoy discussing different things. Also, I want to say that Kaggle is a good place to learn, but the tasks here can be quite impractical in real life sometimes. And finally, the Kaggle community is amazing. It is very friendly, very smart, and I think it's simply the best place to learn and skill up in the field of machine learning. So these are my links. Please follow, and I'm open to new opportunities. Thanks for listening. Stay safe and happy Kaggle.
Thank you very much, Artyom, for sharing your solution and also for sharing with us other solutions. We have several questions though, and we will ask you all those questions after Philipp Singer will tell us his solution for 11th place. So stay with us and we will ask all the questions.
Hi everyone, my name is Philipp Singer. On Kaggle, I am known as Psi. My short name and my on Twitter is Philipp Singer and also on Kaggle. So I just want to give a very short overview of my solution to the tweet sentiment extraction competition on Kaggle. So let me go again over the problem. I assume this has already been covered, but I just want to give again a quick overview. So the goal was to select or automatically select certain passages of tweets that fit to a certain sentiment. So for example, after my very successful finish in this competition, I made a tweet which said, "So happy to achieve one of my big Kaggle goals, competition Grandmaster," and so forth. And in the competition, we had data like this available, so individual tweets. And we knew the sentiment of the tweet. So we knew whether it was positive, negative, or neutral. In this case, the tweet would probably have been positive, and we would have needed to predict the part of the message that fits this sentiment the best. In this case, this might be "so happy." And how the data has been generated was that it was a competition hosted by Kaggle, and it was outsourced to a crowdsourcing annotation company who did these kind of annotations. So again, you have a tweet, you know the sentiment, and you needed to predict the part of the message that fits the sentiment most. What was the issue in this kind of data is that there was a lot of data noise. So just naturally, going back here one slide, I might have selected "so happy," but if another annotator would have selected the text, he or she might have selected "so happy to achieve one of my big Kaggle goals." So it is very natural that there is like no very fixed ground truth or fixed selection that one can strive for, but it is a very subjective and spontaneous thing what one of these annotators would select. So for the same tweet, you could have very different types of selections here. And there were other issues. So for example, here we see that in the end, you have a double point. So now the question is, would you select this or would you not select this? And this is also very noisy and very different in how the data looked like. Frequently, there were cases like things like "awesome!" exclamation mark, exclamation mark, exclamation mark. And then there were different types of selections here. People who never selected the exclamation mark, who selected all 3 exclamation marks or only 1 exclamation mark. So there was a lot of inherent noise in the data, which made the problem very hard to model. Unfortunately, there was also a tiny data preparation issue because the platform that did these annotations did some basic data manipulation, like stripping the spaces in the beginning and in the end. And Kaggle did not adhere to that fully, so some of the labels were even shifted a bit, and people figured out how to properly address this with post-processing or similar techniques. In my solution, I did not use any post-processing, but rather tried to address this noise differently, and I will talk about that for a few minutes. So to give a quick overview of my solution, As many others in this competition, I found that Roberta base models were really sufficient and well working for this kind of problem. I tried other types of models, but nothing came close to Roberta base. I used one that was pre-trained on Squad2 dataset, but this did not make too much difference to just a basic Roberta base model. How you approach this problem with span prediction is that you usually have a linear head for start and end tokens. So if you, for example, have 128 tokens in the message, you would have for each token a separate head for start and end, and then you make prediction what is the probability of this token being the start token and this token being the end token, and then you select basically just the span with highest start and highest end probability. I did a small trick in the model, which was to concatenate the output of the start token representations to the input of the end token representation. So think of first predicting the start token and then adding this prediction to the linear layer for the end token representation. So the model knows already what have been the start representation. I did very typical training routine with Radam or Adam W with Cosin annealing strategy, nothing too sophisticated. To speed training up even more, even though the data was already quite small, I found that removing the neutral sentiment data after the first epoch was working well. So I just trained for one epoch with positive, negative, and neutral sentiment, and afterwards only focus on positive and negative. Why does this work? Because for neutral, most of the data has been selected the whole tweet, so it is way easier to predict. You can already get really good model by just always predicting the full tweet for neutral sentiment, but the tricky one was positive and negative. The models were evaluated with a Shakad score, so how many words you predict are actually in the originally selected text. And this made also all these, going back one slide here, this makes this data noise, specifically with the characters in the end, very tricky, because if you predict goals without this special character here, but the ground truth would be with the special character, your Shakad score for this word would be 0 because you didn't predict the actual full word. So my main solution, or my main trick, if you want to say it like that, was to change the tokenization to address the noise. And I did a lot of bagging and blending. Let me focus on the tokenization. So as I said, it was very important to adhere to these tiny differences in how people select words and text, specifically with the special characters in the end. In the basic Roberta-based Anker-based model, the default tokenization is not splitting on single special characters. So if you look here on the bottom, this is the default. If this would be the word awesome and 3 exclamation marks afterwards, the default tokenization of Roberta base would split it like that: awesome and then 3 exclamation marks. Now think that in our text or in our data, we would have only one special character selected here. Then the model could never learn to only select one here, because it always has the full token of 3 exclamation marks here. So what I did is that I attempted to also split all the special characters into individual tokens. And there are different ways to do this, either through pre-processing and then post-processing again, like splitting here extra spaces. But this is very, very tricky and very prone to errors. So in these kind of PPE tokenizers, you have a merges.txt file, which looks like this. So different lines, and it is stated which kind of subtokens get merged together. This is just a begin token, so a space basically. So if you have something which starts with space diff and then eerie, then diff eerie would be combined, or while, WH while would be combined. But we also have these special characters here. So for example, if it's ... and then another dot, this would be combined to 3 dots. And the same thing with exclamation marks. We have a row here which says exclamation mark, exclamation mark, exclamation mark, and then this token would be combined. And if you just remove these kind of lines here with these merges for special characters, I did this for dots, exclamation marks, and also other special characters like dashes. Then if you change it like that, the tokenizer will split it to awesome, exclamation mark, separate token, exclamation mark, and so on. And then the model can finally learn this type of noise by saying, okay, here it's better. If there are 3 or 4 or 5 or 6 exclamation marks afterwards, it's better to predict 1 or 2 or whatever. And just doing this programmatically helped my model a lot and is basically one of the most important things in my solution. So to summarize, this is already kind of what my solution mainly is about, namely changing this type of tokenization, having a very robust training setup. And as the data was small and the data was also very, very noisy, I already in the beginning of the competition, I decided to always run my CV, which in this case is a simple 5-fold split, with at least 5 bags. So this means that for each fold, I run 5 times the modeling routine with different seeds, and then average the 5 runs. And this gives me a way better correlation between CV and LB, even though the correlation is still a bit lackluster in this competition. But this is also very important because in the final submission, what you usually do is that you blend 5 models, so 5 individual folds oftentimes. So this kind of simulates already how your submission looks like for LB. And as already said, my final solution is based on a lot of bagging and blending. This is also specifically important here due to the noise. So I not only blend these 5 bags over 5 folds, which would be 25 fits already, but I do this several times with several different, slightly different training routines. And as said, the model fitting was quite fast in this competition. So you could already blend a lot of different models, and this helped a lot to make the solution more robust. One of my final subs also includes a blend that is based on pseudo tagging. I did not use pseudo tagging from test data, but rather from CV data. It is very similar to student-teacher setup. So what I did is, for example, take this 5 times 5 fit, average the 5 bags, make predictions, and add this to the general labels as additional training data for another fit, and then you can kind of compress the model by adding this data as pseudo labels. And in this case, you just provide the predicted span as the new ground truth for the labels. As often is the case with pseudo tagging, this can be very leaky. So there are different ways to address this, either to do it in a non-leaky way, like not including the full, but always only including if you have 1 fold and you fit on the other 4 folds, only use the pseudo tags for this model fit, for this fold. Otherwise, it can be leaky, at least on CV, and on test, it usually works quite similarly. Yeah, as said, also other models did not bring extra value. I spent a lot of time on this competition, trying a lot of different models, different fitting routines, different adaptations to the model. I played a lot with post-processing, but unfortunately I was not able to find anything on top of what my model already did with tokenizations. Others addressed this kind of labeling issue that I mentioned in the beginning with the shifted tokens better by either adding it also as some adaptation to the architecture, or also by additional post-processing. In the end, I was very, very, very happy to end 11th here, which was my anticipated solo gold medal, which made me Grandmaster. So I totally achieved my goal here. A lot of great Kagglers, as you can see here on top. So it was a very competitive competition. And even though it has had quite some data issues, and I think many people got frustrated during this competition, it turned out to be quite a good learning experience, also to how to do this kind of span predictions, and also, which is something I never did before, is to change the tokenization. I think this can be also quite valuable for other problems with some very specific data properties. So if there is one takeaway from this presentation and from my solution, is to also think about how the tokenization can impact the model, and keep this open as one further point to explore in future competitions and data science problems. With that, thank you.
Thank you very much, Philipp, for sharing your solution and your thoughts about this competition. And yeah, now Philipp currently works at H2O, and he became double grandmaster after this competition in discussion and in competitions. So now we will have section questions for Artyom. And Artyom, hello. We have several questions. First question from Vitaly Grichachin. Could you describe input in more details?
So let me find the slide.
Well, I can just switch to your presentation and to your slides. So when you will finish explaining, you will just tell me, all right?
Yeah, I found the slide. Could you please show it?
I will show.
So I think you meant this input to the transformer. Actually, it depends on the transformer you use. This one is the Roberto one, and for Roberto, it's pre-trained in such a way that first you always have this token, and for question answering, you have for question answering, it is pre-trained in such a way that first you have the S token, then you have the question tokens, and in this particular competition, we just had a question that basically consists of only one token. Then comes the /s token, /s token again, and the text tokens, followed by the /s token again. So there's not any particular reason for this kind of input. It's just how the model is pre-trained.
Yeah. All right, we'll have another question from Vitaly Grichachin again. Why did you choose average and max pooling?
Average and max pooling, well, it's a pretty famous technique to use with transformer models, because it is proven that because the transformers are pretty deep models, so some of the layers here, they contain pretty different information. Some people say that the first layers contain the syntax information, and the deeper you go, it becomes more semantic. So the reason behind taking average and max pooling is to basically somehow to combine different kinds of information. I believe this technique is also used in the ULM feed paper, but not for transformers, but for another type of model. Yeah.
All right. Another question from Melisovy. Could you elaborate on the target for neutral sentiment tweets? You mentioned that it was often basically the tweet itself. What does it mean?
it means what it means. So like for positive and negative tweets, so the annotator selected the phrase that supports it. And for neutral, well, because the tweet is neutral, it doesn't contain any particular emotion. So there's nothing to choose. And for me, it's pretty obvious to just select the whole sentence. But due to the a little bit noisy annotation, some of the neutral tweets doesn't have the whole text selected. A bit different, but most of them, maybe 97 or 98%, I don't remember correctly, or like that.
Right. We don't have other questions yet, but we will have a networking part right now. You can find the link in the chat. So if you would like to network a little bit with other data scientists, just join. And I would like to thank Artyom for your great presentation, and also congratulations for winning this competition. Also, I would like to thank
you so much,
Philipp, for taking time, and congratulate him for winning solo gold medal and becoming top 4 at Kaggle in the overall rating. So, all right, I would like to close this meetup and see you via networking. Bye.